Alright, this lab is very simple. You're going to be using, after doing the agar diffusion exploration and understanding surface area and volume, you're going to be using a beet to explore more of the surface area versus volume. So what's going to happen is I'm going to provide you with pre-cut strips of a beet. And this pre-cut strip is about a 1/2 inch, 5 millimeters by 5 millimeters by a certain undetermined length, which is not important. When you receive this beet, you're going to bring it back to your table. You're going to put it on your cutting board, which I'll provide each of you. You're going to take a knife, a blade, a dissecting blade. You're going to be very careful, of course. It's designed to cut through skin. And you're going to take your ruler and you're going to measure your strip. So what you want are 3 cubes that are 5 millimeters by 5 millimeters by 5 millimeters. So I'm going to take my ruler. I've already done 2 of the dimensions for you, so you just need to cut them in at length. So I'm going to move these test tubes so hopefully you can see. I'm going to take it off this cutting board because the walls prevent you from seeing. I'm going to take my ruler. I'm going to measure 5 millimeters and cut. And then I can measure 5 more millimeters and cut. And finally 5 more millimeters and cut. So what that does is it gives me 3 cubes. So now 3 cubes are all the same dimension approximately. They'll be off slightly. Do your best to get as close as possible. And then I'm going to take my rinse bottle and I'm just going to rinse it off because there's going to be a little bit of the pigment that's going to bleed from the cut. And I don't want any of that excess pigment giving me experimental error. So I have these 3 pieces that are supposedly the same dimension. So what you want to do is we want to figure out if surface area versus volume affects the way things can come in and out. So this purple dye, the anthocyanin that's inside of here, beta-cyanin, when it is exposed, it will leave the cell and go into the solution. So I'm going to take all 3 of these cubes and I'm going to put them in these 3 test tubes. The first one I'm going to leave is a full cube, 5 by 5 by 5. The second one I'm going to cut into 4 pieces. So I'm going to cut it right down the middle. And I'm going to rotate it right down the middle again. And the last one I want to cut into 8 or 16 depending on your dexterity. So I'm going to cut that down the middle. In the middle. I'm going to flip it and keep on cutting. So what I've done is I've successfully cut my 5 by 5 by 5. One of them I haven't cut. One of them I cut into 4. The other one I've cut into 8. So each one represents a different surface area to volume, but the overall cubic volume is the same. I'm going to put each of these into a test tube. Its own test tube. So in one of the test tubes I have the 5 by 5 by 5. The other test tube I have the cut into 4 pieces, and the other test tube I have it cut into 8 pieces. Now what you're going to want to do is you want to let them soak in water. So we want to have the exact same amount of volume, so we're going to measure the volume using a graduated cylinder. I'm going to make sure I don't tilt it sideways, the straw will just suck air. So I'm just going to do it like this, and I'm going to put in approximately 4 mils of distilled water. So 4 mils in here. 4 mils in here. Four mils in here. All right, so each of these now have their 4 mils of water, and I'm going to let it sit for about 10 minutes, depending on the time that you have to run this experiment. But about 10 minutes is good. Maybe about once a minute, you can twirl the test tubes just to make sure that the water that's around the beet gets a chance to circulate and pick up more pigment. But whatever you do with one, make sure you do with all of them. While this is sitting, you're going to get the probe. So there are two types of colorimeters. We have a blue one, which you can see in the old video, and we have this colorimeter that's obviously in this new video. So you're going to turn it on, hitting the power button. You're going to go to your device, and I hope you can see the screen. I'm going to go to sensor data. I'm going to go to, just move this camera slightly so you can see the screen. I'm going to zoom in here. All right. I can see the colorimeter waiting for me, so 817 is the number I'm using. Now what the colorimeter does is it measures the amount of light that passes through a substance, a liquid. So if a substance is completely black, no light will go through it. If a substance is clear, transparent, all the light will go through it. So there's a spectrum of clear to opaque. And this will measure the amount of light that goes through. Not just the amount of light, but it'll actually look at the frequency. So if you look at this, you'll see that there's violet, blue, green, yellow, orange, red, and those are the colors of the rainbow. And so there's both absorbance and transmittance. I'm going to look at transmittance. I want to see how much light makes it through. So the darker it is, the lower the transmittance. Right? If it's darker, it absorbs light, and the transmittance will be low. It's red. So what is interesting is that when you look at a color, whatever color that you see is what is being reflected, and everything else is being absorbed. We haven't talked about the color wheel, but to make this easy for us, we're going to select red transmittance and blue transmittance. We're also going to select red absorbance and blue absorbance. We're going to go over here to the 1, 2, 3. We don't care about the graph, we just care about the values. So I'm going to click on 1, 2, 3. And the first thing it's going to ask me to do is going to ask me to calibrate. So in order to calibrate this, what you do is you take a cuvette. So these come with little tiny cuvettes. Hopefully you can see it on the camera. And you're going to fill it with water, distilled water. So you don't want it overflowing. You fill it with distilled water. I seal that just in case I knock it over and it's going to spill. I take my Kim wipe and I just clean it off to make sure there's no fingerprints on it. I'm going to place that cuvette in my colorimeter. I said oops because I hit the power button by mistake. So now that I have it sitting in the cuvette, I'm going to put it down so it's not being jiggled, and I'm going to click on the calibrate button. I'll default to wireless colorimeter. I'm going to click calibrate and give it a few seconds. I'll get that check mark, I hit done. So if this was done correctly and I hit start, I should see 100% on the, or very close to it, on the transmittance for all colors, and for absorbance, I should see 0. You can see it's fluctuating. These are really low numbers. That's okay. This is really close to 100. This is really close to 0. So I'm done with the calibration. So I take this out with the water. Now coming back to this experiment here, and I know I'm off camera, so back to the experiment. I have my 5 by 5 by 5 single cube. I have my 5 by 5 by 5 4 cubes, and I have my 5 by 5 by 5 8 cubes. And I'm letting it sit for 10 minutes. At the end of 10 minutes, I'm going to take a look at these test tubes, and what you should notice is that these test tubes, I might be able to notice a difference with my eye. And if I can, that's a qualitative observation. But in science, we want to be as exact as possible. We want numbers to do real analysis. So I don't want to rely on my eyes. I want to measure. And so because one is lighter than the other, I can use a tool that measures the amount of light that's absorbed or transmittance. As a matter of fact, that's the colorimeter. That's what we just tested. So at the end of 10 minutes, I'm going to go back to my colorimeter. I'm going to take these liquids out of the test tubes. I'm going to pour the 0 in. I'm going to seal it, so in case I knock it over, I'm going to take the same Kim wipe I had before, clean it. I'm going to place it in my colorimeter. Make sure that when you put it in the colorimeter, that you have the clear side towards the colors. These colorimeters have a rich side and a clear side. So I'm going to put that in. I'm going to seal it, close it, and then I'm going to record. So I'm going to see that my blue is 71 transmittance, my red is 97. I'm going to record those two numbers. If you'd like, we can record all four numbers. It'll just give you a lot of data to work with. Okay? Once I'm done with that, I'm done with this cuvette. I go over to the second test tube, I do the same thing. I go over to the third test tube, I do the same thing. Notice that I did not hit stop. I just kept on letting it record because all I care about the values. So when I get those values, someone in my group writes down those numbers, and now you have numbers to work with. You should have made a prediction on which one you think would be the darkest, which one you think would be the lightest, based on all the stuff we've done before. And then this lab you're going to put together with the various questions from online, so there's several different activities you can pull together, and this will be your Beet lab, the surface area volume Beet lab that goes inside the lab notebook as one of the major activities for the lab notebook for cells, grade 10. All right? It's that simple. I did the experiment talking through it in 10 minutes. You could probably do it in 15 because I know that you're going to be very careful to make sure you've done everything correctly. All right?